What if I told you that the keys to ripping a traversable wormhole right through the very fabric of the universe might literally be sitting inside your local television radio tower right now, just, waiting for someone to accidentally dial in the exact right frequency?
I mean, it sounds like the setup to a late-night science fiction movie.
Yeah, totally.
But based on the stack of research sitting on the desk between us today, it is rapidly becoming a very, very serious question of applied physics.
Welcome to today's deep dive. I'm just so incredibly excited to have you with us today, because usually when we sit down to talk about a massive new mathematical proof in theoretical physics, there is this heavy expectation of pure abstraction.
Right.
You imagine an eccentric genius writing down a staggeringly complex equation on a chalkboard, and the math checks out perfectly, and the entire academic community just nods, adjusts their glasses, and says, "Oh, how elegant."
Exactly. It's usually confined entirely to the chalkboard. We generally like our extreme astrophysics to remain safely locked away in the realm of the hypothetical.
Keep it on the paper.
Yeah. You solve for X, you publish the paper in a prestigious journal, and then everyone moves on to the next theoretical puzzle. It's binary, it's safe, and, well, it doesn't threaten our everyday understanding of reality.
Purely theoretical.
Right.
But then you step into the world of advanced space-time topology, specifically the physics of traversable wormholes.
Which is a whole different beast.
And suddenly that safe, comfortable chalkboard just absolutely shatters, because we are looking at a theoretical landscape today that has violently transitioned into a literal physical engineering blueprint.
It is the absolute definition of a paradigm shift. I mean, we are witnessing the real-time transition from speculative geometry to applied torsional.
Oh, yeah.
And to really understand the magnitude of what we're about to discuss, you listening right now have to picture the backdrop of our understanding shifting completely.
And let's paint that picture for them.
Okay, so imagine we're moving away from the standard flat chalkboards of classical general relativity. Imagine the space around us right now transforming into these dynamic, three-dimensional, twisting, logarithmic spiral.
Just massive spirals all around us.
Yeah, intertwined with heavy, high-power radio frequency arrays. We're leaving the ivory tower of pure theory completely behind, and we're stepping right onto the floor of a high-tech physical laboratory.
I just love that visual. So here is the mission for our deep dives today. We're looking at a stack of 6 highly interconnected academic papers and technical addendums, all freshly dated March 2026.
Brand new.
Brand new. They're authored by an independent Italian researcher named Rodolfo Rossetti, who also publishes under the rather cinematic scientific alias Atom Descendant.
A great name.
It really is.
Yeah.
And what we have in front of us is nothing short of breathtaking. We are going to explore exactly how Rossetti's work, it's titled Logarithmic-Spiral Tubular Wormholes in Einstein-Cartan-Maxwell Theory, claims to completely dismantle a century-old roadblock in physics.
A roadblock that has frustrated literally the greatest minds on the planet for nearly 100 years.
Right. So we're going to unpack how he definitively solves the dreaded exotic matter problem. Then we're going to see how he takes on and mathematically defeats Stephen Hawking's famous chronology protection conjecture.
Which is huge. The time travel problem.
Exactly, regarding time travel. And finally, most importantly, we're going to translate millions of lines of tensor calculus into the exact radio frequencies, the specific ohm impedance, and the raw power requirements needed to physically build one of these things.
It's an incredible journey, but, before we can start assembling the parts for our sci-fi portal, we really have to understand the foundation. We have to understand why generations of physicists were absolutely convinced that building a wormhole was practically impossible.
Okay, so let's rewind the clock a bit. If I'm holding a textbook on standard general relativity, keeping a wormhole open is basically considered a complete non-starter. Why is that? What is the fundamental brick wall that physics has been banging its head against since Albert Einstein and Nathan Rosen first proposed the Einstein-Rosen bridge back in 1935?
Right, so to understand that brick wall, we have to look at how gravity works in standard general relativity. In Einstein's original framework, gravity isn't a pulling force like magnetism.
It's not a magnet.
Exactly. Gravity is entirely described by the curvature of spacetime. The famous summary by John Archibald Wheeler is matter tells spacetime how to curve, and curved spacetime tells matter how to move.
Which brings up the classic high school physics analogy, right?
Right.
Spacetime's a giant rubber trampoline, and a star or a planet is a heavy bowling ball sitting in the middle.
Yep, the bowling ball.
It creates a dip, a curve, And if you roll a marble past it, the marble orbits the bowling ball because it's just following the curve of the trampoline.
That is the perfect starting point. But now, imagine you want to create a wormhole. You don't just want to dip in the trampoline, you want a tunnel that punctures all the way through the rubber and connects to a completely different trampoline somewhere else in the universe.
Okay, I'm visualizing that. A literal tunnel through the fabric.
Right. And the problem arises at what physicists call the throat of the wormhole. That's the narrowest part of the tunnel, the pinch point between the two distant regions of space.
Okay.
Gravity, which again is just the natural curvature of the fabric, wants to crush that throat closed. Imagine millions of tons of pressure constantly squeezing inward on that narrow tunnel.
Like trying to keep a submarine from imploding at the bottom of the ocean.
Exactly like that. To keep it open, standard general relativity dictates that you must violate a foundational rule of physics called the null energy condition.
Okay, let's unpack this for a second, because the null energy condition, or the NEC, comes up all the time in these papers.
Yeah.
If you were listening to this and you aren't a quantum physicist, the NEC basically states a very common sense rule about our universe.
It's very intuitive, yeah.
Right. It says that for any beam of light traveling through space, the energy density it encounters cannot be negative. Matter has positive energy. Light has positive energy.
Exactly. In standard general relativity, the mathematics that describe the curvature of space, which the papers refer to as the pure curvature sector, clearly show that any normal positive energy matter will always cause the wormhole's throat to collapse instantly. Gravity is just too strong.
It just pinches off.
Right. So decades ago, theoretical physicists mathematically deduced that the only way to hold the walls of the tunnel open is by threading the throat with something called exotic matter.
And this is where the math feels like a total cheat code to me. Because exotic matter is a purely hypothetical substance that possesses negative mass or negative energy density.
Right. Because if normal mass creates a gravitational pull, negative mass would create an anti-gravitational push.
Okay.
It would provide a repulsive force strong enough to counter the crushing weight of the wormhole's throat.
But here is my fundamental issue with standard GR's approach to this. It's like trying to hold open a collapsing million-ton underground mine shaft using magic, glowing, anti-gravity support beams that we have never, ever found anywhere in the observable universe.
That's entirely accurate.
We just invented exotic matter to make the math work on a chalkboard. It's a massive, glaring placeholder for we don't know how to do this.
That is a brilliant way to frame it. It was absolutely a mathematical placeholder. It was physicists saying, well, if we had this impossible magic fluid, the tunnel would stay open. And because we've never observed negative energy in the macroscopic world, wormholes were essentially written off as a mathematical curiosity.
A fun thought experiment, but an engineering impossibility.
Precisely. Enter Rodolfo Rossetti.
Yes. What Rossetti's March 2026 papers do is something entirely different. He looks at the crumbling mineshaft, but instead of searching the galaxy for magic anti-gravity beams, he completely abandons standard general relativity.
He just throws it out.
Yeah. He moves the entire problem into a much broader, much more complex mathematical framework called the Einstein-Cartan-Maxwell theory.
And this is the paradigm shift. This is where the whole field gets turned on its head.
So for you listening, how does the Einstein-Cartan framework differ from the standard Einstein framework we've relied on for a century? I mean, what's the big change?
The crucial difference, the absolute secret sauce of this entire discovery, comes down to one geometric property. And that property is torsion.
Torsion.
Yes. Standard general relativity assumes that the fabric of spacetime can bend, it can stretch, and it can curve. But it assumes the fabric itself has no internal twist.
Going back to our trampoline analogy, standard GR is just about the smooth depression caused by the bowling ball.
Precisely. But Einstein-Cartan theory introduces what is known as a non-Riemannian connection. It says that the fabric of the trampoline can also twist or spin intrinsically.
Twist intrinsically, okay.
Imagine taking a handful of the trampoline's rubber fabric and twisting it tightly like you're wringing out a wet towel. That twisting, spiraling tension built into the manifold itself is geometric torsion.
Okay, so the space isn't just curved, it has a built-in torque. It's physically wound up.
Yes. And when Rossetti evaluates that pesky null energy condition along the wormhole throat in this newly twisted framework, the math completely transforms.
How so?
He uses automated tensor algebra software to break the equations down into sectors. The standard pure curvature sector is still there, and it still wants the tunnel to collapse. But then he introduces the torsion connection sector.
I was staring at the technical addendum for this section, and the math is just wild. It's entirely built on these quadratic torsion terms.
And those quadratic terms are exactly what replaces the magic anti-gravity fluid. In the Einstein-Cartan-Maxwell equations, these torsion terms generate an immense effective positive pressure.
Wait, I have to push back on this, because this is the exact moment where theoretical physics usually loses people. Twisting a wet towel doesn't magically give it anti-gravity properties. How does twisting the empty vacuum of space create physical outward pressure? I'm not buying it yet. How does a geometric twist hold back the crushing force of a collapsing space-time tunnel?
It's a completely fair question, and it's the exact question Rossetti had to answer. It comes down to how torsion interacts with energy. In this framework, the torsion isn't just a static shape, it is dynamically coupled to the electromagnetic field.
Dynamically coupled, meaning they affect each other.
Right. The equations show a precise dynamic equilibrium. As the gravity tries to crush the throat inward, it compresses the twisted geometry. But because of those quadratic terms we mentioned, compressing the twist causes the structural tension of the spacetime to push back outward exponentially.
Oh, I see. So it's like a heavily coiled steel spring. The harder gravity tries to squeeze the wormhole closed, the more violently the twisted spacetime pushes back out to maintain its shape.
Exactly. The repulsive geometric engine keeping the wormhole open isn't a fluid you have to pour into the tunnel. It is the intrinsic coiled tension of the space-time manifold itself.
That's wild.
The math reveals a specific dynamic torsion sector, which shows how the gradients of this torsion actively stabilize any fluctuations along the tunnel. The null energy condition isn't violated at all. The requirement for it is completely transmuted by the geometry.
That is staggering. It mathematically proves that you don't need exotic matter. The century-old search for negative energy fluids is completely obsolete. The tunnel holds itself open just by the sheer force of its own twisted shape.
It completely changes the game from searching for impossible materials to simply reshaping the geometry we already have.
Which perfectly transitions us into the next massive hurdle. Okay, so we know that torsion, this intrinsic coiled twisting of space, is the engine that keeps the tunnel open.
Yes.
But how do we actually shape space-time to create that specific twist? If I'm an engineer, I need blueprints. I need to know the literal physical anatomy of this wormhole.
And this is where Rossetti's work gets incredibly specific. If torsion is the engine providing the outward pressure, the geometry of the wormhole is the chassis holding it all together. Rossetti bases his entire mathematical model on a very specific three-dimensional spatial curve.
The logarithmic spiral.
The logarithmic spiral.
If you're trying to picture this, look at the shape of a nautilus shell. Or, the swirling arms of a hurricane or a spiral galaxy. It's a curve that gets exponentially wider as it turns outward from the center.
Correct. Rossetti parameterizes this core curve by its physical arc length, which he denotes in the equations as S. But a single line, a single curve, isn't a tunnel. To build the mathematics of a three-dimensional tube around this core spiral, he utilizes a classical mathematical tool called the Frenet-Serret orthonormal frame.
Okay, let's unpack this Frenet-Serret frame, because when I was reading the source material, this is where the physical shape really snapped into focus for me.
It's a great visualization tool.
Imagine you are sitting in the front car of a roller coaster, and this roller coaster is moving along an invisible track, shaped exactly like a logarithmic spiral floating in empty space. The Frenet-Serret frame essentially gives you three arrows pointing out from your roller coaster car at all times to describe exactly how you are moving.
That's a perfect analogy. Let's walk through the three arrows. First, you have the tangent vector.
Right. The tangent vector is the arrow pointing straight ahead, exactly over the nose of your roller coaster car, in the exact direction you are moving along the track at any given millisecond.
Then you have the normal vector.
As the roller coaster track curves to the left or right, the normal vector is the arrow pointing directly inward toward the center of that curve. If you're driving a car, it represents how sharply you are turning the steering wheel. And the mathematical tightness of that turn is called a curvature.
Finally, you have the third arrow, and this is the binormal vector. This arrow points straight up out of the top of your roller coaster car, perfectly perpendicular to both your forward motion and your inward turn. And this is where the magic happens. The track we are on isn't just curving flatly on the ground.
It's spiraling upwards.
Exactly, spiraling upwards like a corkscrew or a helix.
Right. As the track twists and banks upwards, lifting out of a two-dimensional plane, your roller coaster car tilts. The weight at which the car tilts, how violently that binormal vector twists, is the mathematical definition of geometric torsion.
So mathematically, constructing the wormhole is like taking a physical, thick rubber hose and weaving it perfectly around this spiraling roller coaster track.
Weaving it around the core curve.
Yes. In topology, this is called wrapping a scaled tubular neighborhood around a core curve. The structural integrity of the tube itself is dictated purely by the interplay of that curvature, the tightness of the turn, and the torsion, the steepness of the twist.
It's a beautifully simple shape, conceptually, but proving that this specific hose actually balances all the forces of gravity and electromagnetism is where human brains tap out.
Oh, absolutely. The mathematics required to prove this shape works within the Einstein-Cartan-Maxwell theory are well beyond human computation. Rossetti had to deploy heavy computational artillery.
The software.
Right. He used advanced automated tensor algebra systems, specifically a software package called Exact, to handle multi-million term mathematical expansions.
Millions of terms. Just try to wrap your head around that for a second. A single equation with millions of moving mathematical variables. If a human tried to solve that by hand on a chalkboard, it would take multiple lifetimes.
And you'd almost certainly make a sign error on page 4,000 that would ruin the whole thing.
Right. You drop one minus sign and the whole universe collapses.
Exactly. The software allowed Rossetti to derive what he calls the master equation. It's the longitudinal field equation that governs the entire wormhole.
The source material has an entire appendix dedicated just to listing the expanded structure of this master equation. And it looks like a foreign language.
It is intensely dense, yeah. But the software successfully decomposed it into 4 distinct, elegant structural blocks. You have a pure torsion sector, a non-minimal interaction sector, a Maxwell sector governing electromagnetism, and a tetratic covariant derivative sector.
Wow.
But the absolute breakthrough here, the realization that elevates this from a neat math trick to a physical reality, is what he formally named the Rossetti Geometric Autonomy Theorem.
Yes. Let's talk about the autonomy theorem.
Yeah.
Because when you parse through the math, the most important part of the equation is actually what isn't in it.
Exactly. The theorem proves that this massive master equation is structurally and completely decoupled from the axial magnetic potential.
Okay, stop there. What does that mean for you and me? If I'm building this, why do I care that it's decoupled from the magnetic potential?
Because if it weren't decoupled, the wormhole would be an incredibly fragile house of cards. Usually when theorists try to design a wormhole, it requires constant, perfect, artificially generated magnetic fields pulsing from the outside just to keep it stable.
Like life support.
Like life support.
Mm-hmm.
If your power flickers for a microsecond, the magnetic field drops and the wormhole collapses. But the autonomy theorem proves that this specific logarithmic spiral shape doesn't need external life support.
Because the magnetic potential mathematically drops out of the equation entirely.
Yes. The throat's existence is dictated strictly and solely by the spiral's curvature and its torsion. It is what we call a self-sustaining topological necessity.
A necessity.
Meaning, once you twist the local spacetime into this specific logarithmic spiral shape, the wormhole simply has to exist to satisfy the local geometry. It holds itself open autonomously.
It's literally woven into the fabric itself. It doesn't need constant babysitting. And then, to make it an actual traversable wormhole that we can use, Rossetti elevates this 3D spiral tube into a 4D Lorentzian manifold. He adds a temporal coordinate, t's, meaning it exists through time, and he adds a redshift function.
The redshift function is vital.
Why is that?
Well, in standard black holes, the gravity is so intense that light gets infinitely redshifted at the event horizon, meaning you can fall in, but you can never, ever get out. Rossetti's metric explicitly prevents that infinite redshift. There are no event horizons. It's a non-vacuum, static, traversable metric. You don't get trapped.
You can actually travel through it, which is the dream. But of course, having a perfectly stable, beautifully twisting tube on a supercomputer screen is one thing. What happens when you actually try to use it?
That is the ultimate test.
Right, so we have the shape, and we know the torsion replaces the need for exotic matter. But is it dynamically stable in the real world? Say I build this 9-foot ring in a laboratory, and I throw a baseball into it. Does the slight gravitational disturbance of the baseball's mass cause the exact equilibrium of the millions of tensor terms to instantly shatter? Does the tunnel violently pinch off and crush the baseball into subatomic dust?
To answer the stability question, Rossetti couldn't just rely on static geometry. He had to subject his mathematical model to what we call radial perturbations. He essentially created a simulation where he violently poked and prodded the math to see if it would jiggle apart.
How exactly do you poke a theoretical wormhole? I mean, mathematically.
He projected the full set of Einstein-Cartan-Maxwell equations onto the radial sector, the math governing the width of the tunnel. He applied a highly complex tortoise coordinate transformation, which is a mathematical trick to handle the geometry near the throat, and he derived a Schrödinger-like equation.
Ah, the radial master equation. And what jumps out from this equation, what practically leaps off the page in the source material, is the effective potential.
Yes. The effective potential is essentially the invisible energetic landscape that any particle or baseball or spaceship experiences as it tries to move through the wormhole. Imagine a topographical map of a mountain range. The effective potential tells you where the steep cliffs and the deep valleys are.
Okay, I'm picturing the map.
This potential is composed of two parts. You have a geometric part and a torsional part.
And as you move closer and closer to the actual throat of the wormhole, as the physical radius of the tunnel gets smaller and smaller, something crazy happens to that torsional part of the equation.
It absolutely dominates the landscape. The torsional term in the equation is defined by the torsion squared divided by the radius to the fourth power.
Okay, math translation time. Because the radius is in the denominator of the fraction, and it's raised to the fourth power. As that radius shrinks down towards zero at the throat, the overall value of that fraction explodes. It skyrockets.
Precisely. As the radius approaches the absolute center of the throat, the effective potential diverges to positive infinity. It becomes an infinitely high mountain peak on our mathematical topographical map.
And this infinite positive divergence is the absolute foundation of what Rossetti calls the Torsional Shield Theorem.
Yes.
I cannot overstate how wild this is. This positive infinity acts as a literal, physical, geometric shield. The theorem proves that because this potential barrier goes to infinity, there are mathematically zero unstable modes in the tunnel. The throat is dynamically protected by an infinite wall of twisted spacetime force.
It's impenetrable.
It is completely immune to radial fluctuations. The baseball cannot collapse it. A nuclear bomb going off inside it couldn't collapse it. It simply cannot crush inward.
But he didn't just leave this as an elegant analytical proof on paper. He had to know how real matter would react when it hit that infinite wall. So he ran a pure physics numerical suite. He used an incredibly advanced symplectic integration algorithm called DOP-853 to simulate actual particles trying to move through this space.
For the uninitiated, why is the DOP-853 algorithm so important here? Why not just use a standard physics simulator?
Because in standard simulators, over millions of calculations, you get tiny rounding errors. Over time, those rounding errors compound, and energy artificially leaks out of the simulation, making the results untrustworthy.
Oh, I see.
Symplectic integrators like DOP-853 are specifically designed to preserve the exact geometric properties of the equations over immense spans of time. They do not leak energy.
And the precision Rossetti achieved is staggering. The solver maintained energy conservation with a maximum relative error of 10 to the negative 13th power.
It's incredible.
That is machine-level precision. It completely rules out any numerical flukes or computer glitches. The torsional shield isn't a glitch. It is mathematically bulletproof.
It is entirely robust.
But the shape of that shield, how the particles actually interacted with it in the simulation, is what completely blew my mind. When you look at the phase space portrait and the effective potential graphs in the addendum, they reveal a massive phase space asymmetry.
Yes, the fundamental asymmetry of the manifold.
Meaning the wormhole does not look the same from both sides. It is a one-way street.
Exactly. This asymmetry arises directly from the exponential tightening nature of the logarithmic spiral. Because the spiral gets tighter in one direction and looser in the other, the curvature and the torsion cross over each other in a way that makes the potential barrier incredibly lopsided.
Imagine you are a skateboarder and you are standing at the top of a massive, incredibly asymmetrical half-pipe. If you drop into the half-pipe from the left side, which represents an inbound particle trying to enter the wormhole from the wrong direction, you slide down, but instead of swooping up the other side, you hit a sheer vertical brick wall of geometry.
The simulation data perfectly illustrates this. The inbound trajectories, represented by the red curves in Rossetti's graphs, hit this extreme torsional gradient. Their velocity drops to exactly zero in an instant, and they are violently reflected backward. The paper literally refers to this phenomenon as a white hole force shield. You cannot enter the wormhole from that direction. The geometry will violently repel you before you ever reach the throat.
But if you are an outbound particle, if you drop into the half-pipe from the right side, represented by the green curves in the data,
you are on the opposite side of the asymmetrical barrier. From your perspective, you don't hit a wall at all. You experience a gentle, monotonically decreasing slope. The barrier simply lets you slide smoothly down through the throat and escape to spatial infinity on the other side.
it is an impenetrable, violent wall from one side and a completely open door from the other. It's a topologically eternal, strictly one-way passage through spacetime.
It is dynamically invulnerable. You can throw perturbations, mass, or energy at it all day long. The white hole force shield will either violently bounce them back or smoothly let them pass through, depending on their direction. But the throat itself will never, ever pinch off.
Okay, so we have mathematically established a stable, completely open, traversable, one-way tunnel through the universe. We've solved the exotic matter problem, we stabilized the throat. But whenever we talk about connecting two distant points in spacetime, we inevitably summon the ultimate elephant in the room of theoretical physics.
We have to talk about time.
We have to talk about time travel. Because general relativity is very clear on this. If you can take a shortcut through a wormhole and arrive at a distant star faster than a beam of light could travel there through normal space, you are not just breaking the cosmic speed limit. You are effectively moving through time.
Time travel is the inescapable, highly controversial consequence of traversable wormholes. If you have a stable wormhole, the math dictates that you can turn it into a time machine. But standard physics has always vehemently, almost aggressively rejected this possibility.
Right. Physicists hate time travel paradoxes. And the ultimate weapon against time travel was forged by Stephen Hawking in 1992 with his famous chronology protection conjecture.
Right. Hawking basically argued that the universe has a built-in cosmic police force. He stated that the laws of physics will always conspire to prevent time travel, specifically to keep history safe for historians. He didn't just say, "I don't like it." He provided a powerful mathematical argument for why the universe would self-destruct a time machine before it could be used.
Let's break down Hawking's cosmic police force because it's crucial to understanding how Rossetti beats him. How did Hawking mathematically destroy time machines?
Hawking argued that if you ever tried to create what physicists call closed timelike curve CPCs, which are the physical paths through space-time that loop back into the past, quantum mechanics would violently intervene.
Quantum vacuum fluctuations.
Exactly. Even in completely empty space on a subatomic level, particles and antiparticles are constantly popping in and out of existence. Hawking calculated that as a wormhole evolves into a time machine, it crosses a boundary called the Cauchy horizon.
And that's the danger zone.
That is the exact moment where time travel becomes possible. Hawking proved that at the Cauchy horizon, those quantum vacuum fluctuations would enter the wormhole, travel back in time, exit, and then re-enter the wormhole again, alongside their past selves.
It's an infinite feedback loop, like putting a microphone too close to a speaker. The screeching noise just gets louder and louder, infinitely fast.
Yes, the quantum energy circulates through the wormhole infinitely. And because it loops infinitely, the energy density at the Cauchy horizon diverges to infinity. This infinite energy spike, which is denoted in the equations by the symbol lambda, would cause an instantaneous, catastrophic radial collapse of the wormhole.
The universe literally crushes the tunnel with infinite quantum gravity, the exact millisecond before you can step through and create a grandfather paradox.
Yeah.
That has been the law of the land since 1992. But Rossetti tackles this head-on in his paper on Chronodynamics.
He does. But before he can defeat Hawking, he first has to establish the exact conditions for time travel in his specific model. How do you actually generate those closed time-like curves in a logarithmic spiral wormhole?
Right. How do you twist space so hard that it drags time with it?
It is achieved through the rotation of the electromagnetic gauge field. In Rossetti's framework, you don't just have a static spiral. You have a massive electromagnetic field running through it. When you rotate that gauge field, it induces a non-vanishing component in the local stress energy tensor, specifically the T-phi component.
I was absolutely marveling at the tensorial block for this in the addendum, the C T5 block. If you dig into the math, it describes the exact non-minimal coupling between the rotation of the gauge field and the Levi-Civita affine connection of the geometry.
That is the mathematical engine of what we call frame dragging.
Frame dragging. Imagine the wormhole is a giant invisible whisk spinning inside a bowl of thick cake batter. The batter is the local space-time. As the electromagnetic field spins, it physically drags the space and time around it into a swirling vortex. If it spins fast enough, it literally drags time into a closed loop.
That's an excellent visualization. So Rossetti successfully establishes the time machine. But the moment he does, he summons Hawking's infinite quantum divergence. The vacuum energy begins looping, the energy density approaches infinity, and the wormhole is about to be crushed.
Which raises the million-dollar question. How does an independent researcher in 2026 mathematically bypass the greatest mind of the 20th century? How do you survive an infinite blast of quantum gravity?
He does it with a brilliant mathematical revelation that he calls the torsional discharge limit.
This is where the Einstein-Cartan framework proves its absolute superiority over standard Einstein gravity.
Exactly. In standard general relativity, Stephen Hawking is 100% right. That infinite quantum energy has nowhere to go, so it crushes the space-time metric. But remember, we aren't in standard GR anymore. We are in a twisted, non-Riemannian manifold. We have geometric torsion, and that torsion changes everything at the Cauchy horizon.
Walk us through what the torsion does to the infinite energy.
Rossetti shows that the geometric torsion naturally introduces a spin torsion coupling term into the equations. And when he calculated the limit as the quantum energy diverges to infinity, he discovered something miraculous. That spin torsion coupling scales exactly identically with vacuum divergence lambda.
Meaning, as the quantum energy grows to infinity, the geometric twist of the wormhole grows an opposing force to infinity at the exact same rate.
Yes. He ran the full 16-term symbolic expansion from the XAMPP software, and instead of blowing up into mathematical nonsense, the equation contracts perfectly. The infinite positive energy of the quantum loop and the infinite negative geometry of the torsion cancel each other out, collapsing into a finite, perfectly stable, bilinear invariant.
Let me try to visualize this for the listener, because this is my favorite part of the entire deep dive. It's like taking a massive, apocalyptic lightning strike of infinite quantum energy. In Hawking's standard physics, that lightning strikes the wormhole and completely shatters it. But Rossetti's spin torsion coupling acts like a cosmic surge protector.
A geometric surge protector, it's the perfect analogy.
As the infinite energy tries to surge through the circuit, the surge protector doesn't try to block it. It perfectly absorbs it. The infinite quantum energy doesn't crush the geometry. It is mathematically swallowed by the geometry. The exact mathematical limit perfectly cancels out against the spin density of the matter field and the torsion tensor.
The result is a finite, manageable number. The catastrophic radial collapse predicted by Hawking's semi-classical gravity is completely eliminated.
The crushing pressure is formally proven to be geometric, not quantum. The twisted surge protector swallows the infinite energy loop without blowing a single fuse, keeping the space-time chronodynamically stable. With that single mathematical contraction, he rigorously formally defeats the chronology protection conjecture. The time machine survives the quantum loop.
It is a monumental theoretical victory. It proves that the universe does not, in fact, abhor a time machine. It doesn't have a cosmic police force trying to destroy time travelers. It simply requires the right torsional shock absorbers to handle the energy.
Okay, my mind is thoroughly, completely blown by the theory. We've solved exotic matter. We've built the one-way shield. We've defeated Stephen Hawking. But as we said at the very beginning of this deep dive, the chalkboards have shattered. We aren't just doing esoteric math anymore. We are building this.
We are turning it on.
Which leads us to our final and, frankly, most staggering section, segment 5, the engineering blueprint. In the papers, Rossetti formally refers to this as the CTEG framework.
Yes. The Applied Einstein-Cartan-Maxwell Torsional for Advanced RF Systems. This is the moment where the papers transition from the philosophical can we exist to the terrifyingly practical how do we plug it in?
So what does this all mean for us? It means we have the exact, literal, physical specifications to build a traversable wormhole in a laboratory right now. The tubular geometry of the logarithmic spiral we discussed earlier doesn't just hold itself open. It acts as a massive resonant amplifier. It is designed to take normal, everyday electromagnetic energy and transmute it directly into torsional pressure.
We are talking about using highly targeted radio frequencies to literally twist the local fabric of space-time. And Rossetti doesn't just suggest this is possible. He provides the exact critical engineering parameters to safely initiate what he calls the electrogravitational torsional field, or CTEG.
The papers state that this framework is designed for immediate integration into strategic high-power RF defense and aerospace facilities. So let's put on our hard hats. Let's break down the actual numbers. If I am an aerospace engineer tasked with building this tomorrow, What am I plugging into the wall? Let's start with parameter 1, power.
According to the blueprint, the system requires a 500 megawatt parabolic transmitter.
500 megawatts. That is a massive amount of juice.
It is massive, but it's entirely within current human capabilities. We aren't talking about harnessing the power of a dying star or building a Dyson sphere. To put it in perspective, 500 milliW is roughly the standard electrical output of a single medium-sized coal or natural gas power plant.
Okay, so we need a dedicated power plant. But pouring 500 milliW of raw radio frequency into a single transmitter dish is incredibly dangerous. The technical addendums specifically note the severe risk of klystron or amplitron meltdown via standing wave reflection.
Which is a very real, very terrestrial engineering problem. If you pump 500 megawatts of energy into an antenna, and that energy doesn't couple perfectly with the target, in this case, the fabric of spacetime itself, the energy has nowhere to go. It reflects backward, hits your own equipment, and instantly vaporizes your multi-billion-dollar transmitter.
Which is why the second parameter in the blueprint is so absolutely crucial, impedance matching.
Exactly. Every medium has an electrical impedance, a resistance to energy. The empty vacuum of space has a natural baseline impedance of roughly 376 ohms. But we aren't dealing with normal vacuum space. Near the wormhole throat, the immense geometric torsion physically distorts this vacuum impedance.
Rossetti's equations, based on establishing a specific spatial torsion of 0.8 inverse meters, calculate the effective torsional impedance, denoted as ZF, to be exactly 482.45 ohms.
That number is critical. Your 500 milliW transmitter must be perfectly, exactly tuned to 482.45 ohms. If it is, the energy will couple perfectly, dumping that massive power directly into the geometry of reality without reflecting back and blowing up your lab.
482.45 ohms. The sheer specificity of that number just gives me absolute chills. It's not a theoretical range, it's an exact dial on a machine. And then we get to the third parameter. What frequency are we broadcasting at this specific impedance? To perfectly resonate with the curvature and the torsion of the logarithmic spiral, the math spits out a resonance frequency found of exactly 45.01 megahertz.
45.01 megahertz. Let that sink in for a moment. That is in the very high frequency, or VHF band.
It's the exact same frequency band humanity has historically used to broadcast analog television stations and FM radio. It is incredibly common, easily accessible, off-the-shelf technology.
It works specifically at this frequency because of what the math calls the geometric Q factor of the spacetime topology. A Q factor basically dictates how well a specific geometric space can store torsional energy before that energy leaks away into the universe as gravitational waves. Rossetti calculated the Q factor for this wormhole to be 16.08, which perfectly aligns with the 45.01 megahertz resonance.
Okay, so let's put the whole machine together. You have a medium-sized power plant pumping 500 megawatts of raw power into a parabolic dish. That dish is perfectly tuned to an impedance of 482.45 ohms, and it is blasting a 45.01 megahertz VHF radio wave into empty space. What actually happens?
What happens next is what the papers call dynamic throat expansion. Upon successful resonant pumping of those radio waves, the geometric amplification factor takes over.
The geometry acts like an acoustic amplifier.
Yes. This amplification factor, denoted as a geom, is roughly 2.5 times 10 to the 44th power. The electromagnetic input triggers a violent logarithmic volumetric expansion of the local space-time fabric. The space literally twists itself open.
It tears open a doorway. And according to the numerical integration of the equilibrium state, which you can see mapped out in the dashboard panels in the addendum, that 500 milliW input stabilizes the tear at a macroscopic throat radius of exactly 2.67 meters.
2.67 meters, that's nearly 9 feet across.
9 feet. That is a staggering number. That is large enough for a person to walk through without ducking. It's large enough to drive a small automated rover or a payload directly through the portal. We're not talking about microscopic subatomic manipulation where physicists cross their fingers and hope to pass a single photon across a nanometer of space.
No, this is macro-scale, physical, real-world engineering. We are talking about building a literal Stargate with a municipal power plant and a highly tuned VHF radio antenna.
It completely demystifies the entire concept of the cosmos. It drags the deepest, most esoteric mysteries of theoretical physics right down to the dirt of applied terrestrial engineering.
It's breathtaking.
It really is. So let's take a breath and do a final sweep of this incredible journey we've just been on. We started by looking at a century-old physics problem. The absolute requirement for impossible negative energy exotic matter just to hold a wormhole open.
Yeah.
And we watched Rossetti completely throw that requirement out the window.
Right. By shifting the entire framework to the Einstein-Cartan-Maxwell theory, he formally proved that the intrinsic geometric torsion, the built-in twist of a logarithmic spiral, creates its own repulsive pressure. It holds the wormhole open all by itself.
We explored how multi-million term tensor expansions calculated by Zach software proved the Rossetti Geometric Autonomy Theorem. This showed us that the throat doesn't need external magnetic life support. It is a self-sustaining topological necessity woven into the fabric of space.
We looked closely at the extreme numerical simulations that revealed the white hole force shield, that asymmetrical, infinite torsional mountain that violently repels inbound matter while gently allowing outbound matter to pass, making the wormhole dynamically invulnerable and strictly one way.
We watched Rossetti use the torsional discharge limit to create a geometric surge protector, perfectly absorbing the infinite quantum energy loop at the Cauchy horizon. With a single elegant contraction, he formally defeated Stephen Hawking's chronology protection conjecture, proving that a time machine is mathematically stable.
And finally, we translated all of that esoteric multidimensional tensor calculus into a stark physical blueprint. A blueprint requiring exactly 500 megawatts of power, pumped at precisely 45.01 megahertz on the VHF band through a 492 ohm impedance array to violently twist open a stable 9-foot doorway through the universe.
It's an incredible amount of information to process.
It is. And for you listening to this right now, I want to emphasize one final thing. We've thrown a lot of heavy terminology at you today. Multi-million term tensors, Levi-Civita fine connections, Cauchy horizons, non-Riemannian manifolds. The mathematics behind this are undeniably incredibly complex. But the fundamental takeaway from Adam Descendant's work is actually deeply, beautifully intuitive. The takeaway is that the universe is not a rigid, unbreakable box. Reality is not fixed. It is highly, fundamentally malleable. Space-time is like a grand cosmic instrument. If you know the exact mathematical shape to hold it in, and you know the exact radio frequency to play, you can twist the very fabric of reality into completely new, impossible configurations. You just have to know the notes.
That is a beautiful way to frame it. The universe is just sitting there waiting for us to figure out how to play the right chord. Which leaves me with one final, deeply unsettling and deeply exciting, lingering thought for you to chew on today. We have just spent this entire deep dive proving that the ultimate keys to unlocking space-time, the keys to defeating infinite interstellar distances and even defeating time itself, do not require magical exotic fluids harvested from the edge of the galaxy. They don't require matter we've never seen. They require a 500 megawatt transmitter tuned to exactly 45.01 megahertz on the highly common VHF television band. So, what happens tomorrow? What happens if a terrestrial military radar station or some rogue, bored aerospace engineer with access to a high-power defense array simply points their dish at the empty sky? What if they mess around with their impedance matching to avoid a system meltdown and they accidentally dial in that exact geometric combination? Have the absolute keys to the universe literally been sitting inside our local radio towers this whole time, just waiting for someone to accidentally push the right button? Think about that the next time you look at an antenna tower on the horizon. Until next time, keep diving deep.